faults here. For page 143, we're looking at where we're going a little bit deeper. We're seeing more of this confining or directed pressure, and we leads to this ductile deformation. So the rock could be warmer till it's hotter as you go deeper in earth, and we're going to see these folds. And so synclines, anticlines. Remember, the key thing about these terms syncline and anticline is that for syncline, the younger strata are always in the middle or closer to the axial plane. So here's a symbol for a syncline, the axial plane of a syncline. And then as you go farther away from the axial plane, the strata get older. And for the anticline, older strata will be at the axial plane, younger strata will be farther away. So that's kind of a key thing. And then here we see the plunge. So these are the plunging folds. So here's a plunging syncline and a plunging anticline. And note that the plunge direction, so on a map, you would see the fold on the map for a plunging fold. And it just shows that the hinge line of the fold is inclined or tilted. For these folds, the hinge line is horizontal. Sometimes these are called symmetrical folds, symmetrical syncline, symmetrical anticline. And these would be plunging folds because the hinge line is tilted or is dipping, and it's dipping or plunging in this direction. So for synclines, the plunge direction is usually in the direction where the fold opens. See how the folds open that way? But for anticlines, the plunge direction will be in the direction where the fold closes, right? So I always think about the older strata being in the middle, and it has to dip underneath this younger strata, which are on the outside, right? So older has to dip underneath younger, and that's how I remember. Whereas over here, older strata on the outside, so older strata have to dip underneath the younger strata, right? So it's inclined back in that direction. And for page 144, we're looking at structural basins and structural domes. And the key to these, you're going to see sort of this bullseye map pattern. So the geologic contacts between different formations, these bedding planes, are going to be circular. And if the strike and dip symbols are all pointing toward the center, then you have a basin. If they're all pointing away from the center, then you have a structural dome. And we'll work on some of these later on. Monoclines and overturned folds, that's where we use those special symbols there. Page 145 are some of the rules for interpreting geologic maps. Remember the rule of V. Number 5, streams cut V shapes into tilted beds and formation contacts that point in the direction of dip. So that's one of the key ones we'll use, especially for this class here. Let's say we have some uniformly dipping strata. So everything's inclined in the same direction, sort of like our figure when we looked at the strike and dip. But in this case, so see how this V shape forms when the contact crosses a stream valley? So there's a little creek or something coming through here. And we'll see this V pointing back in that direction, which tells us that it's dipping in that direction. And the size or the length of the V is indicative as to whether it's going to be steeper dip, or in fact here, the geologic contact is parallel to the contour line. So these other lines represent contour lines. So we see that the geologic contact is parallel to the contour lines, which means it must be horizontal strata. Here, they're pointing back up in that direction, so beds are gently dipping. Let's look here. Here, they're pointing back in this direction. And note that it's a small V. That means it's a steep dip. See how steep it's dipping? So the longer the V, the more shallow the dip. The shorter the V, the more steep or the higher angle the dip. And when there's here, this contact crosses the stream valley and there's no V. When there's no V, that means we must have a vertical strata. So keep that in mind. Remember this figure here on page 145, because we'll need to understand these when we're looking at the geologic maps. All right, so for question number 3 here, just some common ideas here. If you sat on a cardboard box, it's going to collapse. So I want you to tell me whether it's confining pressure or directed pressure. So just put a check mark on one of these. And then, is that an example of a compressional stress, a tensional stress, or a shear stress? So for each of these, you're going to either pick confining or directed, and you're going to pick one of these 3 types of stresses, right? So 1, place a check whether it's for the stress, and 2, place a check for the type of stress. So for number 4, now we have some tectonic settings, right? So I want you to draw arrows here. Draw arrows on each of these figures to tell me which way the vectors are going, right? Which way the vectors are going. So for example, it looks like here we're seeing a subduction zone, so the two vectors are moving toward each other. Also, I want you to tell me what type of stress. Is it tension, compression, or shear? So I want you to do that for each of these diagrams, right? One, draw the arrows, and then underneath here, like for example, this will be compression. You'll draw two arrows going toward each other, and you would say compression here. I'll let you figure out these other ones here as well. Now for this is the problem here. This is an interesting problem, and this is where we're going to use the rule of V's. So let's go to the document camera here. So one of the most important things to do, and one of the simplest things to do, is to color each formation. And I've done that already on mine. I've colored mine. Once you color it, then you can sort of make out what the units, especially when we draw the structure section, these structure sections to show the geology in the subsurface. So I want you to color each formation. I've done that on mine. Then I want you to plot the correct strike and dip symbols at these different letter positions. And here's where we're using the rule of V, right? So going back to that rule of V for contact. So here, so when we have a stream coming here, a stream valley, and note that when the contact between formation M and formation A, it forms a V that points to the southwest direction. So at letter A, it must be striking. So the strike is going to be parallel to the contact. Strike should be parallel to the geologic contact, but then it's telling me that it's dipping back in that direction. So you would draw that strike and dip symbol there. Same thing with B. It's going to be parallel to the contact, striking back in that direction there. And then as I move around for C, I see that when the contact crosses the stream valley, I see no V shape. No V shape. So that must tell me, going back to our figures over here, when there's no V, it must be vertical strata here, vertical strata. For this one, I would put, again, the strike is parallel to the contact, but then remember the symbol for vertical strata is that symbol right there. And then for D, I see that it's dipping back toward the southeast here. Strike is going to be parallel to the contacts right here. Then it's dipping back in this direction right here, toward the middle. Oh, they already have this strike and dip symbol here, right? So these all seem to be dipping toward the middle, these two. All right, so we've done the strike and dip symbols. Now number 3, we want to draw the structure section along this x to x prime. So from x to, well, this kind of got cut off here. This is x prime over here. And we want to keep each formation unit constant thickness. All right, so to do this, since we don't have any data for how steeply these are dipping, and I see that these are not very big V's, it tells me that it's going to be relatively steep. So remember, for each of these, wherever a geologic contact crosses your line of section, you want to place a contact. So that's what I've done now. I've brought down, each tick mark here represents the contacts between each formation. So I've done these for all these. And now I want to show the geology. And again, I'm going to sketch these in because I don't have an actual number, but I'm going to see that this, since its formation is dipping between, the contact between M and A is dipping off toward the southwest. This one's also dipping off toward the southwest. And I'm going to try to keep that uniform thickness there. Then when I go over here, between the contact between P and A, I see that it's vertical, so it's going straight down. And so is this one right here, straight down. So I'm going to just draw it a little bit because I want to show what's going on here in a little bit. Then as I move over here, I see that this contact is dipping about 60 degrees. So it's going to be dipping back this way. And so is this one, about 60 degrees. So now what I want to do, I want to add some color to this so I can see what's going on with the geology here. Now I've added some color to my structure section. I've also labeled formation M, A, P, A, M, and A. And what this appears to be, so because this, all the strike and dips are going toward the middle here, so this must be a syncline right here. So I'm going to show that this is a syncline, something like this. I'm going to try to keep formation A here a uniform thickness, right? And then I can finish off the coloring for formation A. Another problem I have here is I know that on my geologic map I have an older formation here because this is an anticline. And remember, the older units is in the middle in the axial plane. I have this formation S. And this symbol usually means that it's an unconformity. This is probably some disconformity. Then these all strata were folded later on to form the anticline and syncline. So I need to show that formation S is somewhere in the subsurface. Also, I see that formation S is over here. So if this line of section had gone a little bit farther, I would see that formation S would probably intersect right in here. So formation S would come out here, and it's probably going to have a similar strike and dip as all the other formations here, right? So it's going to show some sort of structure in the subsurface like that, right? So I've kind of shown this contact. So what I've done, I brought where that would come down here, and I've shown that it's going to follow the general geology as everything else. So now I'm going to finish up the coloring here. So in the end, my structure section should look something like this. I've labeled all the different formations. I see that I have an anticline here and a syncline there. Now the next question they're going to ask us is we want to draw the axes for the two folds and show the plunge direction. So the axes, so on the geologic map here, it's going to go right through the middle of the fold. So I'm going to draw one fold axis there, and then for the anticline, I'm going to show the fold axis here. And remember we said that for synclines, the plunge is in the direction of where the fold opens, and for anticlines, the plunge is in the direction where the fold closes. So they're both plunging in the same direction. So again, that's going back to here, where for anticlines, the plunge direction where the fold closes. For synclines, the plunge direction where the fold opens. And so we've done that here. So this anticline closes here. We'll draw our plunge direction. And then we also want to add that the arrows, that this is, show the arrows that this is an anticline. And the arrows here showing that this is a syncline. Arrows going toward the middle here. All right, so we do our two symbols there, anticline and syncline. And finally, which formation is the oldest? So if we look at our cross section, formation S. So that's going to be our oldest, and our youngest must be formation M here at the top. So what I want you to do for this geologic map is color. You want to color it, draw your strike and dip symbols. I want to see all those strike and dip symbols, the correct symbols. I want you to show me this cross section here. Color it as well. You want to make sure you color this cross section, label the different formations, draw your plunge and fold axes here, and then tell me which formation is younger or older.